I mean, these MacBooks are fantastic, but all these things you need just to connect to a projector, right? So, hi, welcome. I'm trying to, well, I cannot get my clicker in because I do not have a normal USB kind of thing. So, we'll work it out today because we're going to talk about common mistakes in functional programming. And every time I do this kind of talk and I have this slide on, people say, why the hell did you put somebody on a motorcycle at your first screen? Well, let me tell you just a little story. I mean, I've got a small cousin. He is 3 years old, and if I give him a new present, he wants to do everything with that present. He wants to, if I give him a new toy, he wants to take that toy with him to the bathroom. He wants it in the shower. He wants to go to school with it, to kindergarten. He wants to virtually do everything with that new toy. And the same kind of thing, the same kind of behavior we see with us, developers. I mean, if we have a brand new framework, a brand new way of solving things, a brand new toy, we, maybe not you, but perhaps a coworker, let's keep it to that. We have this thing, we want to solve everything with that. And we all read the documentation, right? We just try it out and it looks like, hey, it works. But it's not particularly the way the framework or the library was designed to do. It maybe worked, but maybe not the good way. I mean, this guy, you can drive a motorcycle from point A to point B like this. It works. But it's not particularly the way it is designed, right? I mean, who drives a motorcycle here? Whoever drove a motorcycle? Just a couple hands. I mean, for those who don't know how to drive a motorcycle, I'm still wondering how this guy shifts gears. Because normally you shift gear with your foot. And it would be pretty impossible to have your foot over there, right? So he is in first gear doing like, and get him from A to B. Well, it works. And it's like this thing, this saying, like, if you have a hammer, everything looks like a freaking nail. I mean, you probably work with product managers, product owners, and you can probably say to them, hey, it doesn't matter how we solve it. If it looks stupid but it works, it is still stupid. Let's be honest. It works, but it's still stupid. I mean, I tend to work with smart people. I hope so. I tend to form my team. I have the ability to form my own team. And I tend to work with smart people. So maybe my product manager is not that tech savvy. He says, well, it works great. Let's ship it. But my coworkers need to fill in for me or need to debug my stuff because, yeah, I do make mistakes. And I can say to my product manager, like, trust me, I'm an engineer, but my coworkers disagree. Yeah, so it's not just a way of solving things, it's solving things the right way and that people can help you, that they can read the code, that they can understand the code, and that they can help you out when bugs are there. Because you and I, we all will make bugs. Or we make software that needs to be improved and improved and improved, you know? First of all, I'm Brian. I'm a developer advocate for Sneak. Sneak is a security company normally, but I've got a background in engineering for the last decade. I've got a background in Haskell, so I did the hard functional programming kind of stuff. Don't ever do that, trust me. It's worthless, except for these kind of talks. So that's why I'm here. So I'm gonna show you a few mistakes, and some of these mistakes are quite obvious though. And that's only a good thing. If you think, well, I know that, then you're on the right track. But these are mistakes I see in everyday project. The first one, don't do too much in a single Lambda. You can put too many people on a single train, but don't do too much on a single Lambda. So what is a Lambda? I copy-paste this from Wikipedia. I'm very good in copy-pasting, like we all do from Stack Overflow. I just did it from Wikipedia in this case. But basically what a Lambda is, it can be the input of a function, so you can use behavior as input of a function, or it can be the output of a function. So except that we only can work with data, we can work with behavior, the so-called higher order functions. And the Lambda is nothing more than a function that is normally not bound to anything. So how can we treat this in Java? We can treat this some kind of way like an anonymous inner function. It's not exactly the same, but you can think of it in the same way. It satisfies the functional interface, and you got two ways of writing it. I mean, you've got an input, a function arrow, and the output, the so-called one-liner, or you got the input, the function arrow, and a whole bunch of code, the function body. Let's go quickly to an example, just to warm you up. In red, you will see a higher order function. This function is pretty silly, because the input, it doesn't do anything, it just prints something, and it applies the function on the beer I gave. But it's a higher order function, because we take the behavior as an input to our method in this case. If we want to call this function, and that's the more interesting part, we do that over here. You see that in my handle beer call, I want to give behavior. And what I want to do is simply, I want to print out the name with something else. In this case, the alcohol percentage. A lambda is meant to be concise, because we want to have this readable. If you do this, and you give it as a parameter to your function, you should write it like this. But can you imagine, and yes, I've seen this multiple times, that people will write a lambda and give it to a function, but the lambda is more like this. We're trying to do if, else, try, catch, switch statements. I hate switch statements though. And trying to shove it all inside one lambda and give it as a parameter directly in your function. Well, I can relate to these people if they say, I hate functional programming. Yeah, if you do it like this, I do hate it too. Because if you do more than one thing in a lambda, you have to ask yourself something. Do I apply separation of concerns? And maybe you do. Maybe let's not be dogmatic and say you have to draw it in one line. Maybe you need to do more than one thing in a lambda. Well, who is a Java programmer here? Who has been a Java programmer here for, say, at least 5 years? 6 years? 7 years? 8 years? Since 1995? Since 1995, we have something in this language that we can solve this with. It's called a method. By simply putting all of this crap in a method and doing a method reference and giving the method a great name. That's the hardest part, because we have to think of names, right? You can keep your higher order function readable. And for instance, all these functions on the Stream API are higher order functions. And the thing is with these expressiveness of functional programming, or actually declarative style of programming, is we want to make our code more readable so that people understand in one look that what the code does. So if you need to do more than one thing in a lambda, just make a method. This is our secret, right? Let's continue to the next one. This one is very debatable, because stream is the new thing, and let's return streams, use it everywhere. Well, we have to first know, what is a stream? Well, a stream is not a data structure. That's important. And the second most important thing is that a stream is not a data structure. So let's continue. But what is a stream? Well, a stream is some kind of fuzzy. I mean, it's a flow of data derived from something like a collection. Wow. Yeah. Okay, we can create these awesome pipelines with it, but the most important part is it's an intermediate result. So that means that if you write a document and you do not want to yet publish it to your boss, because maybe you need some review on it, maybe you need some work on it, the intermediate part, you know, your draft function, your draft part, that's what a stream is. It's not the final thing. It's lazy. I love lazy though. And they say you can transform data, cannot mutate data. I will come back on that one. If you have a stream like this, an easy stream with strings, I can map a function over it, and I can collect it to a list. We've got two sorts of things: intermediate functions that give you back a stream and preserve that laziness, and you've got the terminal functions. And the terminal functions actually make something useful out of that stream, like a list. You've got the map reduce kind of algorithm, and the mapping kind of thing is that the intermediate functions and the reduction to a single value or a list, that are the terminal things. So the terminal things make it worth. So there's one thing on a stream, because you can only use a stream once. I mean, if I output this one, then you see the second line. You see that I bind this beer.stream to a variable. Don't ever do this, because a stream is not meant to be used twice. So why in name, should I bind it to a variable? Because if I do that, then you probably want to use it twice. Don't. But because that means, like, the first time I use that for each, it works perfectly. But the second time, and you probably think, well, hey, if it works one time, let's do it again. It doesn't, because a stream can only be consumed once. So say you give back a stream from your API. How can you be sure that somebody, or you're using a stream from somebody's API, how can you be sure that this stream is not already consumed? You can't, because there's no such thing like stream.is already consumed. There's no such thing. So you have to have faith, and that's what we all have in our fellow programmers, right? Yes, please don't do that. I'll trust you. So I won't say never return a stream, but be careful with it, because when you want to return a stream, what are good ways to return a stream? I mean, if you have your private intermediate function that returns a stream to preserve that laziness, to work on that draft document, perfectly fine that you return a stream, because, well, it's not yet the final thing, right? So you create your own tools. When your stream is created every single time you call that thing, it's a new stream. List.stream gives you a new stream every single time you call it. If you have such a function, perfect. If you call, for instance, a very large data set that probably doesn't fit in your memory, then because of the lazy evaluation, it is a good thing to call a stream. Because, well, I worked at a web shop vendor, like the Dutch Amazon, and if I want to load all working shopping baskets into my microservice in memory, well, that probably explodes. So then a stream would be useful because lazy evaluation. But by default, and learn this please learn this to your juniors as well. Make sure that you return some sort of thing like a collection, because you can use that over and over and over again. It's persistent. So don't by default go to stream. The exception is going to a stream instead of the other way around. Next one, because I'm having to rush in it because, yeah, well, time things with projectors and kind of thing. Mutable objects. Who likes mutable objects? Who uses mutable objects? And the rest is still asleep, right? Yeah, sure. Okay, let's look into functional programming. What is functional programming in general? Again, I'm a good copy-paster. But okay, you see this whole story? Don't read it. There are a few things important for functional programming. And that are the bold things, underline bold things. It works with functions. It avoids changing state and mutable data. It's declarative programming paradigm. And it works with expressions instead of declarations. Fair enough. But if we work with mutable data, then you have functions that can mutate that object, right? So, quoting my favorite scientist, Miss Dr. Albert Einstein, insanity is doing the same things over and over again and expecting different results. Well, you probably have never worked with mutable objects. I mean, if I have a mutable object and I can mutate it inside my function, then something different comes out. And I use that same object and I do it again, then something completely different comes out. How can you keep track of that? It's insane. I mean, by working with immutable objects, you make it yourself harder to read, but harder to write, but easier to read. Because it's an effort to work with immutable objects. It really is an effort. And yes, you have some more memory consumption, and yes, but you have to look at it. Who works in an enterprise here? Like big companies, large server parks, yeah. Then probably the effort is more in how can I maintain my software instead of how can I be that smart and do it all nifty. No, you want your coworkers to work with you as well. So with immutable objects, you ask... Yes, we're back. Don't touch the laptop too much, Brian. Actually, what we want to do is that a function or a method should only ask questions. I mean, if I ask you, what is your favorite color? And you will say, blue. And I ask again, what is your favorite color? If you say red, you've probably been drinking, but most of the time, you say blue again, right? And asking that question shouldn't change your opinion instantly, or shouldn't change your opinion at all. And the same thing is with objects, or with immutability. Asking a question should not change the answer, nor should asking it twice. And that makes your code more reasonable. We can reason about code. We can say, hey, if this comes in, this comes out. Perfect. So now debugging would be much easier. If we have this one comes in, but it depends on the state because it can be there. And I have to keep that mental mind map in what state is my object, what the outcome will be. Then you're like debugging over and over again, pushing F8, F8, F8. So it's easier to reason about, you have less moving parts, and you do not need to keep that mental mind map. Well, earlier I said within streams you cannot mutate data, right? Streams cannot mutate. Well, let me go to some code, because talking is cheap. Let's put this on a next screen. Yes. All right. So, first of all, revert this. I need this later. Don't touch the laptop too much, Brian. Revert. Yay. Okay. Mutate. Is it visible for everybody? Yeah? Cool. So, if I want to do something like this, I want to mutate in my stream, and I say map, and I have this beer. I have a list of beers over here, right? You see the list of beers, and I want to mutate something on it. Beer dot say okay. Beer dot set name. That is not possible because we cannot mutate. We can only transform. But if we look at what the problem is, it said no instance of type variable R exists to that void conforms to R. So I had a smart guy in my team, and he thought, well, I can fix this. So what he did, he went to that type, and he said, we have a setter here, and it void and R, that's the problem. Let's go back to that function. Let's run it. Hey, I fixed it, ship it. Yes, you can mutate. And you see that I print the new list over here and the old list over here. You see that actually I did change the name of that object. But we were talking about mutability, right? And that immutable objects would be nice. Well, of course, we can use the forEach. I will come back to that later because I hate that again. But what should you do if you want to do this? Well, let's do it like this. For the sake of argument, make it with name. And instead of creating a setter, creating a new function that gives with name, and instead of mutating the existing object, what I do here now is return a new beer with the new name and the old alcohol percentage. So I actually create a new object over here. By doing this and running it again, you will see that, if it runs of course, that the new list contains the new names and the old list stays in touch as it is because, well, in this simple example, it does no harm. But I don't know if that list is used anywhere else. And by changing it, it can hurt somebody else's stuff that I'm not responsible of. And then all unit tests go red. Or, well, if you saw the examples that Victor Renta did, some stay green because, well, some people do good unit tests, right? Anyway, you can mutate data, but you shouldn't. Please don't do that. Let's go back to the slides because I have far more. Where are my slides? There. So, you can, but you shouldn't. Return a new copy, and that way you can keep that lazy evaluation going, and you're transforming the object instead. But we have the forEach. I already talked about that, right? The forEach. If you do a forEach on a stream, it's one of the terminal functions. Keep track of that. It takes a consumer, and it can be used to apply side effects or mutate data. But what you actually do, it's simply a for loop without an external iterator. It's nothing more. It's just syntactic sugar. And don't get the perception that because you're working with a stream, streams are lazy. I can use the forEach because it's lazy anyway. Normally, you can do something like this. With the forEach, we can apply a side effect on a list of streams that, in this case, prints all the things out. And printing is considered a side effect. We can also mutate what I said. But what people now are doing, and again, this is a real life, or no, it's not a real life example with beers, but the construction I'm going to show you was real life. People were doing this. And it wasn't with beers, it was in this case with something more clever in the financial sector, which I cannot name because of a non-disclosure agreement. But what the person was trying to do here, it was within a batch job. We had this list of beers, and we want to enhance that object with third-party information. So for instance, from that beer, I want to have the ratings from point A and put that inside my object. I had the reviews for point B. I want to do that and put it inside my object. And the person thought, hey, this for each thing. And I love that declarative way of programming. Now everybody understands what I'm doing. Done. He was right, because everybody understands what he's doing, right? For each statement, I want to set the rating, and for each beer, I want to set the reviews. Just keep in mind, if you have 14 million entities, what are you doing here? forEach is a terminal function, so it traverses from top to bottom over your whole set. Doesn't matter if it's a stream or not, because it's a terminal function. If you do that again, like by enhancing it with the reviews, again, you're going from top to bottom. Basically, what you're doing is you're doing twice the for loop. And everybody knows, like, okay, I can do that in one for loop, right? So if you need to do this, if you actually need to enhance an existing object, don't do it like this. Just use an ordinary for loop. We have that since 1995. What you also can do is create transformers that create new objects so you can preserve that lazy evaluation. It depends on what you want. But you have to be careful that a terminal function sets up the whole set from top to bottom. And the longer the set, the longer the problems. We managed to rewrite this, and from a 14-hour batch job, it came back to a 4-hour batch job. Pretty nice. 5-minute work. Here, where's my bonus? All right. Order of operations. Now I need you to think. I have an assignment for you with these beers. Every beer has a brewer, and every brewer is from a country. And now I want the first 3 unique brewers' countries from the beer library, and I want to print it as a common separated value. Is this correct? Who think this is correct? Who thinks this is wrong? Who is not sure? Who has no clue what is written here? Who is actually a C programmer? Who is a manager? No managers, luckily. Of course it's wrong. I'm talking about mistakes, right? The problem is here. Because we distinct over the brewers, and we limit on 3. So I get the 3 brewers. But I don't know how it is here, but in Holland, where I live, we have multiple brewers in the same country. I have 5 in the same city. So I don't want to distinct over the brewers. I want to distinct over the countries, because the assignment was the 3 unique brewers' countries, right? Who does unit testing? So you will all find out because you write excellent unit tests, right? The point is that the things that you do inside a stream will be traversed or will be evaluated from top to bottom. So it does matter in which order they are. But because we write unit test, you will find out, and you have, well, the problem is we have the wrong data. It doesn't crash or something. And if we write good unit test, we will find this out. But, it's always a but. Say, I have this part. I have this nice int stream. and I distinct over it, and I limit it to 10, and I want to print it out. Okay, more abstract kind of assignment. What you see, what it's doing over here in the corner, you see it prints a 0, it prints a 1, and it is still running. You see? It's still consuming my CPU, around 100%. Okay, but what is happening there? The problem is, let me just write it out for you. This one gives you a 0, a 1, a 0, a 1, a 0, etc. You feel me, right? The distinct gives you a 0 and a 1. Oh, 0 and a 1. And then the next series said, oh, I already have a 0. So the limit gives you, the first item is a 0, the second item is a 1, and I need to limit by 10. So the third item is, and it's waiting, it's stuck. That means that we do not get to the forEach statement. Well, we do for the first two statements, the 0 and the 1, and then it's stuck. Can you imagine what will happen if you do this? Come on, let's try it out. Just for fun. It doesn't give me any result, but it does consume my CPU. And it's getting warm here, so let's quit this one. Okay, because in parallel, what does it? In parallel, you use the fork join thread pool if you do not specify your own thread pool. And it forks and tries to parallelize the things that are intermediate, so the distinct and the limit. And it forks at the point of the terminal function. And there's your problem. Because the parallel thing is stuck with the limit, it never comes to the terminal function, so it will never joins again. So it doesn't give you any intermediate results, but it does consume your CPU. Who works in the cloud? Say AWS, Google Cloud. Try this. And you're sure that you will not get a bonus. But it's fun. No, but what should you have been doing? I mean, it was order of operations, right? I mean, by simply changing the order of operations and making sure that the limit was not here, but here, you will end up with, at first, 10 items, and then you distinct. You will see that it terminates. Of course, you can be smart and say, well, hey, if I limit it to 3, then it will, or 2, because I know the iterator only gives me 0 and 1. But the point I want to make is that you have to be sure that you have the order of operations correct. Second thing that you have to keep in mind is these infinite streams, because of lazy evaluations, are cool. But why should we use them? In how many cases do you need an infinite stream? Virtually none. Because most of the time we do something, say for instance 10 times. Normally you would create a while loop or a for loop, and you can create a stream with a range from 0 to 10, or a range closed or whatever. Or you want to traverse over a list, so you don't need you don't need an infinite stream. You need a stream that's just as long as the list, which just list dot stream does the trick. So basically, going back to this function, I told you about this. Infinite streams will run forever. Cool. Solution. Look closely to the order of operations and prevent the incorrect results, but we write unit tests, so no problem. Skip this. Only use an infinite stream when absolutely necessary. We've got range closed. From Java 9 and up, who's on Java? Who is on Java 8? Who is on higher than Java 8? So there are a few things that are nice in Java 9, 10, and 11. For instance, in Java 9, you have this iterator if you want to use it, and that can hold a predicate. So you know that your iterator will finish at the end. If it doesn't comply to that predicate, it will cut off. And it's better that it will be cut off than it doesn't consume your CPU, right? Especially in cloud. Whoever did create their own higher order functions? Cool. So I can't tell you anything. Higher order function. Well, we can not only put data into my function as a parameter, but also behavior. And that's cool because we can now create a new level of abstraction, and by that, reduce boilerplate. Say, for instance, I have these two amazing functions. Ta-da! And say my first one, the logger up function, does some super interesting thing, which I cannot describe because, yeah, I have to kill you, of course. It prints something in uppercase, and then it does some super interesting things afterwards. What most people do is like, okay, we need the same function, but now we have to switch on one, we have to change one thing. And then you see people like, select it, copy, paste, change that one line of code, ship it. And that works perfectly. Until you have to change something, right? Because then you have to change that super interesting code in the first function and in the second function. And actually what we want to do is that only that one red line is the difference between these functions. And these functions can be like 10, 20 lines long. So why not abstract that only line that we want by doing this? I still have that log upper and log lower, but in this case, I'm having my higher order function, which takes a function as a parameter and applies that. So by a single line lambda, I can now create my upper and my lower case. And now if I have to do something in my super interesting code or my more interesting code, I only declared it once, so I only have to maintain it on one place. Yeah, that's all cool. Stupid, silly example. Well, we did this in practice. I worked for one of the major web shops in Holland. It's bol.com. I don't know if you know it, but you can resemble it to the Dutch Amazon. It works only in Holland and Belgium. But what we had a MongoDB cluster. And that MongoDB cluster had a primary node and a few secondary nodes. The primary node you can read and write on. The secondary nodes were read-only, because most of the things were read-only. But if you want to change something, say for instance, we were doing the service that holds all shopping baskets, and you want to add something to your basket or remove something from your basket, then you have to read and write, because you have to read what your current state is and write what your new state is. And it can only be done on the primary, because we do not want to read from the secondary, because there can be some latency between the two. So we have to read from the primary. We do some edit on it. It doesn't matter what. We had to run the rule engine if it was legal what we were doing, and if, for instance, a client has the right of a promotion or a deduction of his price, or it was possible to combine these two products, all kinds of business rules, and then we have to save to the primary. And we had to do that for the add, the delete, the whatever. Every single action that needs to do a write on that primary basket or the primary database, we had to do that. So the point that we want to abstract was that added part. So what we did, instead of just copy-pasting it, we created something like this. We created a mutator, and the mutator by ID, which was the ID of the basket. And we gave it an action. So we read from the primary, we applied that action, add an item, delete an item, add a discount, add a coupon, delete a coupon. It runs the rule engine, what the new price would be, because if you add something, you want instantly, a client wants to see what's my new price, what do I have to pay? You cannot do that on the background. We need to have that instantly. And we save it back to the primary database. So by having my add item and my remove item, instead of doing the same things over and over again, and then I already abstracted the read from primary over here because it was much more longer than that, I only had to implement one function with its own consumer, and now my code was very much more readable and very much more adaptable to new things. Because after running the engine, there were some things we had to add again, because one of the business people said, this is cool, let's do that. And instead of doing that in all the edit functions, I only had to do it in one. So it is useful in the right setting. Who likes optionals? Who hates optionals? Few. Okay, I can relate to that. Because Venkat would kill me. Who was at that keynote? He said the person who ever called that M word first line. I would not talk to him again. Afterwards, I came to him. Optional is kind of the maybe monad of Java. Yeah, sure, whatever. What it tries to do, monad is not that hard. It's just, it wants to encapsulate certain behavior. In this case, the fact that it can be null. In Java, it's just a wrapper. But with an optional, we enforce our users to look into it instead of blindly using it, right? By using an optional, you know, hey, it can be empty. Cool. So you probably think that an optional can be empty or can be filled with something. Think again. This is possible because we live in an object-oriented world. So people who do this, please shoot them in the leg, because everybody deserves a second chance, right? Now, please do not do this. We're having the same problem all over again. If we just promise each other here that we never bind an optional to null, then we do not have that problem. But it's practically impossible to do that within the Java language. So you can do this, don't do it. So now we have to unpack that optional. And we have that optional over here, and we say get. But there's a problem, because you cannot just get an optional. One cannot just get an optional, because it can be empty, and it gives you no such element exception. So what you see multiple times is that people do this. Let's check if it's empty or not. That's cool, it works, ship it. Can somebody tell me how this is any better than just your old-fashioned null check? It is not. We are doing the same thing, but wrapped in an optional. Still need to guard it with an if statement. But that is not how an optional was designed to be. I mean, if you want to do this, use the things that are there. I mean, optional has this if present, and if from Java 9 and up, if present or else. It has this map function. And with the map function, the map of the lambda inside the map will only be evaluated and will only be applied if that optional is filled. So by using these things that are already applied with an optional, you do not have to do these ugly if-else statement around that optional to make it work. Yeah, that is cool. But what if I want to do something else with an optional? I mean, say for instance I want to have an optional, and if it's not there, I want to do something completely different. So I have an optional example over here. I have an optional that is filled with foo. We have three options actually. You can map, I can map a function over it, and if it's not there, I throw an exception. Well, I can do is to empty and the exception will be thrown, but you probably believe me. But say we want to do something else. Say for instance, I want to not only run if exist, but say I want to create a new function and I say run if empty. That doesn't give me anything. I print just for the sake of argument, only run if optional is empty, and I will give back the string empty. Well, let's just remove this one and say, what do we have over here? Or else. Looks great. Run if empty. And if you see this on first glance, you'll probably say, okay, this optional is filled with foo. It will be mapped. So at the end, we will print foo. Right? This will be printed like foo. Let's run it. Well, my unit test is green because it prints foo. The only problem is that both only run if optional is filled and only run if optional is empty are both there in my trace. Why? Because I did the thing that you wanted. I used the functions that are there. And there's the problem. Because we are so used to the fact that or else shortcuts everything, or the if-else statement. If the if is, or the map in this case, is met, that the or else will not be evaluated. But there's the problem. The or else was not meant to be used like that. The or else is only there to supply you with a default value if the optional is empty. Not with different behavior. if you want to do different behavior, there's another thing called or else get, and it takes a supplier. And there's the funny thing in it. Because it takes a supplier, it doesn't have to be evaluated right away. And if we run it now, we will have the behavior we desire. It only runs the if exists and not the if empty. And it's a subtle difference, right? Or else get. But if you make this mistake, say for instance, I want to look if that user exists in my database, or else I want to create it. If you do that with the first thing, then you end up with or collisions in your database or a very, very angry database administrator. Both of them, it's not good. So, although the difference is subtle, there is a difference. Or else will be evaluated. That's because of the nature of it, and I can go into the code, but do that yourself. Just look at it, into it. Because encapsulation doesn't mean we don't care. We actually do care. Only we cared of it once, yeah, it's okay, and we can use it. We do not want to write it all over again. So, that means that, let me get to the point over here. If we have that, if you want to use that or else, make sure that what's in the or else doesn't contain any side effects, because everything that's in the or else will be evaluated. Or else is actually just designed to give you a default value. If I do not do anything, just only give you the string empty, then it works perfectly fine. If you want to have an alternative flow, please use the or else get. It takes a supplier, and it will take care of it. That distinction, I made that mistake once or twice by doing, fast fix, run to production, and then bam, 3 o'clock in the morning. Not nice, right? So difference subtle. Make sure that that you use it. How much time do I have? How many? 15. Ah, well, maybe I will skip this one for later. List of options. Who knows what this is? And don't say a rocket. Duh. Or does anybody have an idea what this is? Almost. Sorry? A filled lunch. Yeah, no, it's not a filled lunch. The lunch was actually good. Halfway in the air, it went wrong. It's the Ariane 5. It was a project from the European Space Agency, and there was a problem with that thing because it wanted to convert a 64-bit long value into a 32-bit unsigned integer value. You see the problem? And it measured the velocity of that thing. So when the velocity was low in the beginning, it worked perfectly fine. And then the velocity became outside of that amount that we can cast from one to another. And then we had some sort of exception. And then the second part happened. The point I wanted to make here, exception handling can be useful. So, say I have this function, do something, and I want to use this in a lambda. And this do something function can have an exception that is empty exception. And yeah, I'm sorry, before I look at my glass, I have to catch if it's empty or not before I drink it, right? So it's a checked exception. Can I use this in a lambda? No, you can't. Not instantly. So how can we manage that? Say I have example over here. I have a function over here that just randomly generates an exception. Nothing special, but just for the sake of argument. And my exception is a checked exception. So I have this list of beers, and I want to map this do something function over it. It doesn't work, because it says unhandled exception, exception, my exception. Okay. Well, how can we solve this? Just a second. Don't touch the laptop too much, you know. Try catch. Hey, that's cool. Throw new runtime exception. Ta-da! Fixed. But still, I mean, we just promised each other that we won't do too much of these silly things in a single line lambda. Well, I can fix it as well. And we call it try sum. Good. I'm so good in naming. Okay. Then I replace this with a method reference. Cool. Now works, right? Whoever did this. Like, I have an exception, I need to check it. Let's put it into a runtime exception and continue. 1. Honest, sir. You're honest. Thank you. I did it. I did it more than 1 time. Actually, I do it multiple times. But that's a whole different story, because I think checked exceptions are not the best way to handle these things. Because most of the time, I think in the things we wrote or I wrote, if there is an exception at that point, that it would be end of the world. Because, for instance, I/O exceptions, I would check before I actually do this thing if that file is there. And if in the meantime my disk was unmounted or somebody pulled the plug or something, then it should crash. But okay, say this is one of the ways to handle an exception. If you want to handle it in a runtime exception or not, maybe you should do a specific thing here. Then this is your way to go. If you need to catch that exception and do something at that point, then you should probably do it like this. There is no nice way. Or is there? Well, say for instance we want to just move it into a runtime exception because we hate checked exceptions and they will never happen in my program because yes, I'm that good. How should we solve this? Should we do this every single time I want to use this function? Why? You can abstract this. Let's go back to the original one. Say, for instance, I want to abstract this. And I can do this by simply, first of all, creating my own functional interface. Interface. Spelling is hard. So, public interface. And, well, let's call it check function. Right? Cool. Then I have to, oh well, it's a functional interface. Let's annotate it. So I write the apply, and in this time not only just a function, throws exception. Don't do throwable exception because throwable can be nasty, but again, I can spend a whole presentation on that. Say I want to, normally I would do this in a different file, but just for the sake of argument, I do it over here. I create a util function, and I say public function wrap. I'm a wrapper. And it takes the check function, and I do all of this over here. So instead of just simply transforming my function with a checked exception to a normal function by doing once and for all applying the function 1 time, and then it says, of course, yeah, we have to do the try and catch. Perfect. I do it over here. Throw new runtime exception. And now what I can do if I just abstract this and put this in a util file and put it down, 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 where somebody will never find this in my repo, in my original file, I can simply do this. And it works. So if you need to do this, abstract it again. And you can wrap it, and still my map function is quite readable. But there's a problem with it. Let me look, and let me run this. Oh, it throws an exception. Ah, great. But you see what it did? It had 3 beers in the beginning. And the first beer was good, and the second beer had an exception. And then it broke. So what do you see? If a function like this, it works. But if an exception does exist, it kills my stream. And if my stream is not just 3 items, but 3 billion items, and it fills at 1,400,422, then I have a freaking problem. because I have to do it all over again because I have no clue where it broke. Yeah, maybe if I find the logs, like, okay, start from there and have to write custom code. Actually, what we now see is the runtime exception breaks out of the stream. Is that nice? I would rather traverse over the whole stream and at the end find out what went wrong, what went right. And just do something with it. Throw the wrongs away. Maybe that's good enough. Retry the wrongs. I don't care. Or just keep the wrongs and the rights were okay. I don't have to look at it. I want to be in charge. To do that, we have to introduce something new. Whoever worked with Scala? You've heard of the either type? Of the try? Well, we're going to introduce the either type. And for those who don't know the either type, let me just give you a tiny overview. The either type. Either type is just like the optional wrapper type. It doesn't exist in Java, but you can write it in 10 lines of code. It can have a left for the viewers and a right. It cannot be both. It cannot be left and right. So it can be or a left or a right. So that means it can be, if I have an either string integer, yeah, good spelling. It can be a left of string or a right of integer, not a stringiger or an interstring or whatever. So it can be one of both, not at the same time. And because we use generics over here, we can wrap everything in it. And by default, what they do in functional programming is that they use the right part for the right part and the left part for the wrong part. So say we have this either of exception and object. So we put, if there is an exception, we put it in the left part, and if it's something good, we put it in the right part because, well, object is still the main thing, right? Everything inherits from object. Going to the code back again, and I will show you the real example of either. You see that either here is either a left or a right. It has a private constructor. So actually what you can do only is you can instantiate it with the left or the right. It's a very naive implementation. You can do a better job, of course, with inheritance, but this fits on one page. But what we do over here, I created a function called lift. And you see what I do over here? I did do actually the same thing as we did with that throw runtime exception. I do the try and catch, but if it works out, I pack it into the right part of an either, and if it goes wrong, I pack it into the left part of an either, which makes it that my stream will traverse from top to bottom and will give me a list of either's, and that can be cool. So if I go back to this thing, and instead of this wrapper function, I use this function that I just showed you, and which is either.lift, right? And when I run it now, you will see that, well, the first thing went right, the second thing went wrong, and the third thing went wrong as well. If I run it again, it will be different, of course. But you see, it does not break my stream. At the end of the row, I still have the stream traversed from top to bottom, which can be a good thing. This one is a nice example. Right, left, right. Because I want to have that third right. I want to have that. So instead of seeing an exception as something bad, just treat it as data and use that lazy evaluation from a stream and decide afterwards what you want. So because now if I can filter on the rights and I only have the good parts and throw the bad parts away, I'm in charge again, not my runtime exception. But there's still a problem here because, okay, left one, the second one went right. Can I do something with it? The exception is not very useful, right? It says, well, I know that's something wrong. But I do not have the original value anymore. But because an either can hold everything, you can choose to not just have the exception in it, but to have the original value in it. Or the exception and the original value, if you want to, because, well, generics, objects, we can wrap it. Let's go into that either again, and look what I did as an example over here. I called it lift with value. And instead of in the left only throwing the exception, I choose to use pair, which is a thing that is available in Apache Commons, but you can again write it in 2 lines of code. I wrote it over here. This is pair. Yay. It's just a wrapper that can hold 2 things. But for the sake of argument, you can do anything in that left part. So if I do live with value, I now have the exception and the original value. So I can redo it and redo it again if I want to. I'm in charge. And that's the most nice thing, because I do not like to be that my program is in charge. I want to be. I'm the programmer. You have to listen to me. You filth. No. So by lifting with value and running it again, I have all the information I have when something goes wrong. I have the exception, which can give me useful information, doesn't at this time, but I also have the original value, so I can redo it, or know what went wrong and inspect it, or whatever. Again, I'm in charge. By filtering and redoing it, again, I can do whatever I want, and I do not break out of my stream. I think this is one of the best ways to handle exceptions within lambdas, within streams, within the lazy evaluation of streams. Then people who worked with Scala or even with Java Slang, it's now renamed a few years ago as Favre, said, well, we have the try, and you can use it as well. Yes, of course, the try has these nifty functions as lift and lift with value as well. But the problem with try is the first thing I showed you with either was that we have the exception or the success. The try is basically that. It can hold the exception, nothing more than that, and the success. If you only have the exception, you just hope that the thing that's inside the exception, for instance, the string that he outputs, is valuable enough for you that you can work with it. So again, you have to pray. With the either type, you are in charge and you can do whatever you want with it. So by using that either type, you can put in the stuff that's needed in your use case and do the lazy evaluation and make sure that it works from top to bottom. And I think I'm almost out of time now. So I will end with this slide. The try I just told you has the same thing. Failure that can have the exception and success that can have the type. Look at that library. Look at Favre. Take a look at it if you want to do functional program, because it has a lot of nice new stuff in it which can help you if you dive deep into it. Only if you want to only use it for exception handling, come on, write your own either type. It's 10 lines of code. And I will publish it for you. So you can just copy paste it and say, look what I've wrote. Yes, it's not that hard. Because then you have to think of yourself, do I want to implement a whole bunch of libraries or a whole big library that maybe is just a few K but has a lot of functions on it, and you want to depend on that just for this amount? I mean, if you only want to use string utils, do you import whole Apache Commons? I hope not. You see what I'm going to? So you have to think of that if in your use case you want to import a library that is bigger than that, or just implement it yourself. And that's up to you. I'm not going to make that choice for you. So I want to end with this slide. My name is Brian. I work for Sneak. We have this new kind of nifty thing, the secure developer, which goes into secure development. If you're into that, please take a look at it. It's free. It's not commercialized. We had the first session with Jim Manico a few weeks ago, which was fun. He threatened me with a sword during that webinar. Just look at the video. It was fun, though. This is my Twitter handle. I will publish the slides. I will publish the code. Just look at my Twitter handle and you will find it out. If you have questions, I don't know how much time I have because my watch is digital and it broke. Oh, time is up. If you have questions, come up to me or just tweet me. Don't be afraid. Tweet me. I will answer you. Thank you for coming, and enjoy the keynote and, of course, the beers.